The modern battlefield is a lethal place to be a large, loud, moving object. When a 60-ton piece of machinery rolls into a combat zone, it instantly becomes the ultimate prize for every drone operator and missile team. For more than a century, engineers have dedicated their careers to designing weapons with one specific job: destroying tanks. Yet, despite being a massive, noisy target, the tank refuses to go extinct. The history of this machine is a high-stakes game of action and reaction. Every time a new weapon threatens to pierce its armor, the design adapts to survive. Its existence is defined by a continuous life-or-death arms race. To remain relevant on the front line, it has to constantly evolve. To see where that evolution started, we look back to World War I. Millions of soldiers sat in trenches, separated by strips of cratered wasteland. If infantry tried to advance across no man's land, they were cut down by machine guns firing 500 rounds a minute. Military leadership was desperate to break this bloody deadlock. They needed a mechanical solution that could cross the broken ground and survive the relentless incoming fire. The British answered with the Mark I. Built secretly under the cover story of mobile water tanks, this was a giant rhombus-shaped box on tractor treads. For the crew of 8 inside, conditions were miserable. With temperatures over 100 degrees and exhaust fumes filling the cabin, every bump rattled their teeth. But when these machines rolled onto the Somme battlefield in September 1916, they delivered a massive tactical shock. They simply crushed barbed wire and shrugged off the rifle fire that had previously halted entire armies. They were far from perfect. Early models were slow, unreliable, and frequently got bogged down in the thick mud. Even with those flaws, the Mark I proved a crucial concept. Mechanized mobility could shatter static defensive lines, ending the era of the immobile infantry stalemate. During the 1920s and 30s, military thinkers focused on fixing the tank's early flaws. The first designs were essentially blind and deaf, with crews relying on hand signals to communicate. A German officer named Heinz Guderian recognized that speed and communication could solve this. He developed the doctrine of Blitzkrieg. By installing radios in every vehicle, commanders could finally talk to each other on the move, allowing tanks to operate as fast, independent spearheads. This doctrine allowed German panzer divisions to slice through Poland and France in a matter of weeks. Instead of fighting every entrenched enemy head-on, these columns bypassed strongpoints to attack supply lines and headquarters, paralyzing the enemy's ability to respond. As the war progressed, German doctrine shifted toward massive, heavily armored machines. They deployed 57-ton vehicles like the Tiger I, equipped with thick frontal steel and an 88mm gun capable of knocking out targets from over a mile away. While the Tiger was complex to produce, the Allies focused on reliability and volume. The Soviets designed the T-34 with sloped armor to deflect fire, while the Americans built the repairable Sherman. Both countries produced over 50,000 of their models. World War II demonstrated that victory relied on constant radio communication, rapid coordinated movement, and an industrial scale that could replace losses faster than the enemy could inflict them. After the war, thousands of American and Soviet tanks faced off along the Iron Curtain. During this standoff, new anti-tank weapons emerged that could cut through solid steel like a hot knife through wax. To counter this, British engineers developed Chobham armor, using layered ceramics and metals to shatter incoming shells. Engines also evolved. By installing helicopter gas turbines into the rear hull, these 70-ton vehicles could suddenly reach 45 miles per hour. Targeting technology also advanced. With laser rangefinders and thermal imaging, an enemy's engine block glows bright white, even in pitch darkness or heavy smoke. The Cold War added technical precision to the tank's brute force, creating a surgical predator capable of hunting targets 24 hours a day. On the modern battlefield, the threats are even more sophisticated. Infantry carry anti-tank guided missiles capable of punching through 2 feet of solid steel. To survive, engineers developed active protection systems. Turret radars automatically fire pellets to destroy incoming missiles mid-air. These vehicles also act as digital nodes, instantly sharing threat data with nearby infantry, artillery, and a drone to form a unified network. We are also seeing a shift toward heavy automation to keep crews alive. Designs like the T-14 Armada feature a completely unmanned turret, placing the human operators safely inside an isolated armored capsule. Modern survivability relies on a fundamental shift in strategy, preventing the hit entirely through digital awareness and active interception, rather than just absorbing the impact with thicker armor. In recent conflicts, multi-million-dollar armor is routinely destroyed by inexpensive drones. This brutal reality frequently leads critics to declare that the tank is finally obsolete. Yet armies continue to deploy them because nothing else brings this specific combination of firepower, heavy armor, and mobility to the front line. They can clear paths through concrete walls and deliver precise fire to entrenched positions. The platform is actively evolving to counter new airborne threats right now. Crews are bolting on anti-drone cages and installing electronic warfare jammers to disrupt incoming signals. Over a century of development, the clumsy iron box of the Somme has been replaced by a thermal hunting, digitally networked fortress. Every time its demise is predicted, the design adapts. As long as ground forces need to take and hold physical territory, this machine will continue to evolve,